So, I am Stacy, and I'm here to talk about Android animations. More specifically, the many ways to animate and potentially get robbed. There are so many ways to actually do animations in Android that it is overwhelming. And a lot of the times there's only one or two variants of an answer that are actually going to get you a decent performance and actually be something that's usable in your application. So let's talk about some other things, namely libraries that are kind of important to know. Lottie. How many people are familiar with Lottie? I hope everyone is, actually, because it allows you to take your Adobe After Effects animations and make them real. And actually what it does internally is it actually writes those as canvas animations. So they're actually pretty high performance. There's iOS, Android, and React Native files that it outputs, so it's a one-time drop, which is really simple. You actually import things as a Lottie drawable, and that means it's super simple, no real dev work. You basically add the animation. There's a couple of casting things that you might need to do, but other than that, it's pretty simple. And it handles very complicated animations very easily. And there's an awesome little location here called lottiefiles.com that you can download a lot of pre-built Lottie files so that you can start playing with them in your application, or even just borrow some in order to make something a little bit more pretty and animated. So again, talking about Lottie, there's some problems still, right? So what I've noticed is that there's a lot of performance and scaling issues for full screen. And this is something that you can run into with canvas animations in general, because remember, you still have to handle things in on measure, and if you're not doing anything in order to size appropriately for the screen, it's going to start from a center point and go out, and maybe you want it to bounce on the edges, or maybe you want it to have certain things there. It's going to, in a lot of ways, still act like if you put a GIF or something along those lines, or a video file. It's not going to necessarily scale correctly, and because it is actually running in full screen, those animations have to be super optimized in order to work well, and you're going to run into performance issues. It's not an issue with necessarily pure Lottie problem. It's kind of an issue with video memory and scaling and all these kinds of things that we aren't necessarily taking into account when using a Lottie file. So in relation to that, how well your Lottie file runs is very, very dependent on how optimized the After Effects file actually is. So if your After Effects file has not been optimized and has some multipathing and some like weird features that it's using that nothing else is, you're gonna have problems. The performance is directly one to the other, because that's exactly where the canvas animation file is actually pulling all of those paths and then doing that animation, translating it the whole 9 yards. So if it's just not there, it's just not there. And when I say not as efficient as handwriting in Canvas, I'm talking about if you were doing like geometric animations, things along those lines, things that are mathematical. In fact, there's a lovely article that we have from our group about doing geometric animations in Android as well as in iOS, and how each of those are done, and how that is actually optimized. And we talk a little bit about some of the stuff that we saw with Lottie in that area. So what's another thing we should know about? Kyrie. How many people have heard of Kyrie? No one has heard of Kyrie. Okay, so this is another Alex Lockwood product. I say that with all terms of endearment. Alex has done a lot in terms of vectors and animation and things along those lines for the community. And this is an alternative to AnimatedVectroDrawables, but actually it's a subclass of AnimatedVectroDrawables and VectorDrawable. So it addresses a number of issues. How many people have tried to use VectorDrawable and found them to be a major pain in the... Everybody, yeah. Trying to put them together sucks. Keyframing, handwriting it all out, it's not possible, right? In a lot of ways. So there are some nice things with it in that you just, once you've made it, you put it in your little file folder and it exists, but there's a problem with that. It only shows up with your application. So if you wanted to create something at runtime, you'd have to assign it, right? And it's also not possible for you to just define paths in, say, like an API and actually use a vector directly in your application based off of pathing information, is it? This allows you to do that. It's really nice because you can basically render an SVG from API. And most importantly, for animated content, you have your start, your stop, your pause. You can do some more things with the keyframing, especially if you had a specific transition that you wanted something to be toggled off of. There's just a lot of niceties there. Shapeshifter. I touched on this just a moment ago. Shapeshifter, again, another Alex Lockwood product, is this online tool for building animated vector drawables very easily. So what you see there where it's doing those transitions between the buttons and the button states, and if you actually look at a number of Google's applications, they're actually using vector drawables that are built using Shapeshifter in those production applications because it's so much easier to actually build an animated vector drawable. So it's an automated tool. It requires no code experience to use, but it does have its own learning curve. I would suggest that you actually watch 2 videos directly related to this. Alex has been spending a lot of time trying to address some of the usability issues. He is aware of it. He is putting time towards it, and that's very, very nice. But again, just like Lottie, you get to build for Android, iOS, and web. But what's even nicer is that your compatibility with web is much, much higher because you're actually building things as CSS files. So that's pretty awesome. And there's a nice video right here that actually allows you to kind of play with some of that stuff. It's not bad. I highly suggest it. So why don't we start looking at some code? Oh shoot, no. Okay, so I want to show you first this phone that I have. So in this phone, we are running a very simple animation set. And I'm picked these because they're pretty common sets. So what we have here is a fab that has 2 other fabs, right? So that's a fairly simple animation, right? We're doing an expansion, we're doing some alpha. It's basically just scale and alpha, really. And we have right here, you can see 5 different ways to actually do it. In fact, it's a lot closer to 12. There are 12 different ways to do this same animation, and that's before we even start talking about writing it in C or using external libraries or any of those kinds of things. We're talking about purely just using Android animation library sets. There are 12 ways to get the same thing. But not all of them are right. Let's kind of start from the beginning. What's the first example that you see when you're actually using Android for the first time on how to write animations? It's usually what we effectively call, and I list here as XML, right? View property animation, or view animations, not view property, view animations. So when we come into here, you can see my actual code. We're just doing some simple button states. And our first animation is here. So all I do here is I'm just setting values to make sure that each time when we switch all the different buttons in the way that can animate, that at least tries to make it right. And for here, we just have a start animation, and we make it clickable, and then we make those other little buttons not clickable, right? So our fab 1 or fab 2. And our is fab open, because there's 3 fabs. So what does that look like in terms of the XML code? So if we go to our .anim, we have our fab open and our fab close. And you can see it's super simple. We're just doing a simple animation set here, and we're setting the scale. We're just saying it's 300 milliseconds. We don't want it to scale quite to full size. We want it to be 0.8. We want a linear interpolator on the scale animation, and we want the alpha to have an accelerate. Super simple stuff, right? Everybody feel like it's super simple? Say yes. Yes. Yes, okay. But there's some issues with that. So actually, if we start looking pretty detailed into what's happening here, do you notice that they aren't exactly at the same time? Are you noticing that one animation is actually happening just a moment before the other? And it has to do with how we're calling them. So if we look at the actual code here, we're saying start animation and start animation. Now, in talking to some people who know how this works at a much deeper level, and it actually shouldn't be doing that, but the reality is that it does. And they're off by usually one single frame. But one single frame, everybody here can see that, right? So don't you think your people are going to notice? Right? It's going to feel staggered. And that's only going to get worse. Your frames are going to get skipped more and more, and that buffer is going to be larger and larger depending on how performant the device is. What we have right now is an emulator. That's about the most ideal situation that you can, right? Nice BP processor, plenty of RAM, nothing else running or compiling at the same point in time. This is an idealized situation, and we still see it. All right. So we're kind of working through our way on the next example that we see in Google World. And on this area, what we go to is the .animate, right? So this is where we start to get into the view property animator. So what we have here, and I kind of messed it up there by switching it while it was still in the other thing, so it's only going to 0.8 of the higher one. This is another thing to take into account. Some of these you actually have to pay attention to their end and beginning states. And that's actually dependent on the animation type. Why is that not a consistent behavior? I don't know. But it's marked here in the code for good reason. But again, we can see it's essentially the same animation here. If I did a kill of this, you should be able to see that if I select down to animate, because I started it in a weird state, now it's okay. That actually seems a little bit cleaner too. It's not as clicky. Did you notice that with the other one? So when we came to here, oh, now it's broken. I broke it. When we came through on the first time, what we saw was, did I not kill this? I'm pretty sure I killed this. Oh, okay. So do you see how clicky that feels? It's not working like it's a float, is it? How would you know that that wasn't actually float values based off of the XML that we put in? You wouldn't know that. It feels jaggedy, it's skippy, it makes me angry. Makes me angry. Little bit, not crazy. But all right, so now that we're at the .animate type, right? Which, this app, emulators, they're fun. So on here, we can see, okay, so we're still seeing that delay between one and the other, but now when we actually run the animation, we see, wow, that's way smoother, isn't it? On that scale animation and on the alpha. And you can see that even on this display. So imagine how much more you can see it on an actual phone. So, all right, we got this part. And what are we seeing here? Honestly, it's pretty simple to actually write out, but I do have to give it It ends with actions for setting visibilities and all that kind of stuff. We have our linear interpolator here. We have to do a scale X and a scale Y. Luckily, you can put those together if they're using the same interpolator. That makes it quite easy. And actually, under the hood, what this is actually using is Object Animator, which we will get into in a little bit. But this is actually pretty high performance. Now, we still run into the problem where there is that skip because we're not actually orchestrating, right? So what you can see is each line, I'm calling out an animation that I want to have happen. I'm not telling the system that I want to have all these animations happen at once. I'm just calling them in sequence, right? So of course we're going to have stuff that just gets missed, and we're going to have a moment where, yes, the two aren't going to animate together. This will end up being a conversation that you would probably have with your designer, and this could end up being a fight. How much nicer is it that we don't have the fight? Now you actually know, okay, if I'm just going to animate something once, right? Or if I'm just going to animate a single object in a single way, I can use this and it'll have no performance issues whatsoever. Or if I need something else to animate independently and the two don't have to be coordinated together, this is perfectly fine. It's going to be perfectly fine in order to accomplish that. But also take into account that when you do a bunch of these animations at once, you're gonna end up using more resources than you absolutely need to. There's an orchestration layer that we can get into in just a moment that'll help make that a little bit nicer. So, what's the next type? Let's go to the standard dot animation. That's kind of the next thing that they actually show you, right? So in the standard animation type, I'm just going to default kill from now on. So, ooh, okay. So some progress here, right? At least they're starting at the same time, but now we've gone back to the clicky. Why is it that this feels, that isn't smooth? That isn't smooth on the expansion. We've gone backwards in one way and forwards in another. Why? This is where it gets into a little bit more of a tricky thing. Okay, so now we've actually started to introduce orchestration because we have animation type, right? So we're using the built-in scale animation and alpha animation. And even though, for all intents and purposes, we're still calling these animations in sequence, because of what's actually going on underneath, they actually know to orchestrate together. Even though, in terms of code, you're looking at the previous one where one was starting before the other and it was called in the same way and it seems like it's doing the same thing. But here we're calling them together and yet they are actually coming in together. Okay, this is again where we get into that very confusing area. Rough. Okay, so we made some progress. We're still not there yet. All right, we can do this. We can do this. Everybody believe we can do this? Yes. We can finally make a pretty one. All right. So, all right. Let's try one more. Let's try one more. I swear we'll get it that one of these days. It'll be great. So, all right. Object animator. Let's see. Okay. Oh my God. It's perfect. It's perfect. It's beautiful. It's beautiful. Okay, let me show you it again. Everybody, when it goes off, say ooh. Ooh. Look at that. We got no clickiness. We have the alpha animation running perfectly. We have the scaling animation running perfectly, and they're both happening together. Okay. I'm glad that you got it this time around. All right. We're getting there. We're getting there together. All right. So in terms of this, all right, we're seeing a little bit of a trend. We're seeing a little bit of a trend here. Yeah, look at how much code that is. Yeah. That's way more code. Okay, so this is when we did it in animation, right? Like it all fit on that one page. Okay, and this is when we did it just with the .animate, like view property animator. Look at that. Look at how small that is. And oh my God, look at how tiny this was when we did it in XML. But look at how big. Yeah, we're still, oh, yep, this is still to open. Yep, look at that. So the moral of the story is, in a lot of ways, if you actually want to write something that's performant and orchestrated, it's long. And the thing is here is, I'm going to tell you, there's one actual animation type you really need to know. And it's pretty much Object Animator. Object Animator is actually a subset of Value Animator, and if you actually look at what a lot of the animation utilities are using in some way, shape, or function, they are actually tied directly back to Object Animator. So if you actually dig quite well, you will find that everything else is using that, and there's a reason behind it. It's right. It's the right way. I mean, it's not the only right way. It's not the right way for every situation. But if you had to say what was just the way, this is probably the way. So what we have to remember here is that in Object Animator, we actually have to declare things like, okay, I'm going to make an Object Animator. I'm going to make it float type, and I have to pass it the type of animation. I have to do scale X and scale Y separately. You don't just go say like scale X, Y, I don't know why. And not only that, you're going to have to, for the most part, if it's not a view.type on the animation, you're going to have to remember the actual string for it. Now, some of the animations in Object Animator do not have a view.whatever type. You're just going to have to remember this weird string. Like for a translation Y animation, you're not going to find it. So that's one thing to consider. We see that we have to declare the interpolator twice. We have to do the accelerate interpolator. We have to add a listener to turn things off and on again. Okay, so this has ended up being, it's right, but it's long. All right. It's right, but it's long. Let's see if there's. All right, let's see if this still looks. Whoa, that looks the same. That looks the same. Same pretty, same ooh. But I see it's probably slightly different. But let's find out why is it slightly different. So all right. I want to introduce you to something you probably haven't seen. It's this thing called Property Values Holder. So instead of actually having to declare my animation each time individually for all objects and put them in as Object Animator of float and then literally say fab1 and fab2 and do that and copy paste and things like that, I can start to just say, okay, I want to make an animation type of X, Y, and alpha. And then I can take that and I can apply them to my objects. So that's pretty cool. And actually, if the interpolators were shared across multiple animations, we could have actually just made them all one property value animator together. So there's a lot of different ways that you can concatenate code and make it a lot more simplified in terms of animations using Property Values Holder. And it is exactly an Object Animator at heart. It's just something to make it a little less code, a little bit more simplified. But there's some other stuff I put in here just for funsies, because I thought it was pretty interesting. One thing being, ooh, pretty, text color. There are not that many ways, or not that many right ways, or let's be honest, ones that work, ways to actually animate text with color and those kinds of things. Again, you can take this code and insert it into an object such as a spannable so that you can animate certain things. But if you just wanted to animate just the text of a button, there's some code I included in there for you there. But okay, there's another hidden animation here. I want you to pay very close attention. Everyone, very close attention. If you're looking at your phone, I'm looking at you. All right? Okay. So, watch what I do here. Ooh, rotation. Okay. Well, okay, where's that written? Okay, let's take a look at it. Some pretty things. Oh, it set me back. Okay. So what we're doing here is we're just going to animate some things based off of, we're going to animate each of those to do a rotation. It should be pretty simple, right? Like these look like they're the same code, right? So we say that fab, we want it to animate, we want it to do a 360-degree rotation over the course of 500 milliseconds, and we want it to have a decelerate interpolator and it to start as soon as we hit it. And this looks the same, right? Like we're going to put a rotate animation from 0 to 360, so it's going to go all the way around, decelerate interpolator, same amount of time, and we want it to start, right? These look like the exact same code, just written different ways. So we'd already done the first one. Let's see what the second one looks like. What the? What? I thought we meant rotate. Did we not write rotate? Did we not write that the same thing twice, right? This is where it gets into the BS of what's present. There are lots of ways to animate, and sometimes what looks like the exact same code is in fact totally different code and doesn't do what you expect it to do. And sometimes when that's happened, you have to just spend your time searching. And I wish I had a better way other than to say pretty much just learn Object Animator and learn what the view properties are that you need to actually animate and do that, because you can run into so many problems that will just hang you up like that. Why is it not rotating? Why is it rotating around a magic pivot I didn't give it? And why is it doing it? I didn't have that in the, if you look at the actual code, there's no pivot point, there's no anything in the layout. Like it just decided that's where I'm gonna rotate and I'm gonna do it backwards for some reason, counterclockwise. Doesn't make sense to me. So this is kind of the core of Android animations, and I want you to spend some time understanding it. And please take this code. What I'm also going to do right now is we're going to finish this up with some other resources you should know. So if you want to take that code, ooh, there you go. It's all nice and updated too. But there's some stuff you may need to forget. So I know we just went over a lot of things about writing actual Android animation code, and apparently Java wants to install an update right now, at most inopportune moments. So how many people are using constraint layout currently in their applications? How many people have even played with motion layout? All right, we got one actual and one like, What? So I've actually done a lot of work in testing, a lot of different kinds of motion layout stuff, more so on the Alpha 2 than the Alpha 3 because the Alpha 3 has only been out for like a couple weeks. There's still some issues there, but it's considered app production ready. So it's actually built on kind of the stable version of constraint layout. So it won't mess up your constraint layouts. It has all the latest of constraint layout, but it also has motion layout, which has been really kind of fun to play with in a lot of areas. And, you know, We haven't found any issues. I haven't found any issues in actually using the Alpha 2 or Alpha 3. Performance is great. Actually, it's fantastic. It's actually acting at a deeper level than Object Animator. It's actually writing things directly to the surface, which is fantastic. So it's going beyond Canvas. So the performance, very, very high. There's still no Java Kotlin generation API, so it's still XML declarations only, even though now we actually have listeners and we can actually get positioning information and other things like that from that motion layout. We still don't have the ability to write it out just like we did in the code a moment ago. You only get one motion scene per layout, although they have added the ability to do more than one click per layout. So that has been really nice because it used to be that you basically got to do one action with your layout and one reverse action. And that's a problem because there's a lot of multi-stage animations here. What's kind of nice though is that even with a motion layout, you can still use the traditional Android stuff, right? So you can still use traditional Android animations with constraint layout and with motion layout to accomplish what you need. And motion scenes can get quite long. A lot of it is copy, paste, and then change a few little parameter names. And sometimes you copy and paste twice because you have a start state and an end state. So yeah, it's long. It's long. It's long. They know it's long. They know we don't like it long. But there's a reason for that. There's going to be a UI motion tool that's actually fairly similar to Adobe After Effects that we've actually seen, talked about at Google I/O, and as well as some other presentations, especially when they show some of the key staging and things like that. They're actually using a tool that they have not yet put out, and that tool is essential for us to be able to make really high quality animations without having to spend a lot of time. I feel like a lot of the time I can actually write the code a lot quicker using just Object Animator and translations with fades and things like that to accomplish that just due to experience. But maybe other people can't quite as easily. So, you know, it's still like, okay, what are you using it for and what do you need, right? But what we will have is something that's just like animations currently, apparently, as far as what, you know, wink, wink, I've been told, is that we will still have an animations API for motion layout. It'll make it a lot easier. So keep your eyes peeled, and I do suggest that everybody at least play with it and the examples that are out there, and there's some wonderful Medium blogs on that. I do want to point out some great additional resources. This Get Animated was a presentation at the Android Dev Summit. It goes over some of the more technical bits of what I kind of talked in a very layperson manner about specifically with animations and Androids and what you should actually use. Highly recommended. They also go into some more details on constraint layout and motion layout going forward. Android Animations Spring to Life, again by Doris. How to use physics animations, things like that. Animating on a Schedule, talks about the Google I/O application going forward. And just look at the animation overview on the Android site. And that's it. My name is Stacy Devino. Pleasure. And please grab the slides here.